Hello, it's Mr. Van On here with week 4. Is it week 4? Oh my goodness, time flies. Week 4 after spring break, so no more sweatshirts. Day 1, math. And today we're going to be working on converting metric length. You need to be on page 847 of your book and following along. I've left this up here for the next several lessons so we can refer to it. But the bottom line is, can you remember King Henry died unexpectedly drinking chocolate milk? Just writing down the first letter of that little story to help you as your tool to show your work. That's the expectation for showing your work on something like this, just to be clear, is writing KHDUDCM, and then on each individual problem, tracking how the decimal moves. That's how we show our work to show our understanding that we understand how the decimal moves in the metric system, depending on how you're converting it. So let's jump right in. Metric system. They've got you. You're doing stacking. You don't have to do that. We got this cool chart. So we're going to convert all of our measurements today using the chart. So there shouldn't actually be any stacking, multiplying, dividing, things like that, because we understand that when we multiply, decimal shifts once to the right, and when we divide by 10, the decimal shifts once to the left. Let's do that. So the problem is, one of the largest recorded pythons measured 7.3 meters long. What is the length of the python in centimeters? So I've got 7.3 meters, and I'm taking it to the streets. I mean centimeters, and I'm taking it to centimeters. If your parents are watching, they got that reference, but I bet you didn't. So anyway, we need to go from meters to centimeters. So I point at where I'm starting, which is meters. Meters being the base unit. So I'm starting with the base unit, and I'm going to centimeters. To get from the base unit to centi, I go twice to the right. Did you see I went once, twice to the right? So guess what happens to the decimal? It also shifts twice to the right. Now, anytime my decimal, if I look ahead and say, yeah, I'm gonna end up shifting, like I don't have space here, I just write it down again. But Mr. Van On, that took a second to write down, and I don't have a second. Just write it down again underneath it when you're shifting the decimal to the right. You'll be happy you did it because you're less likely to make mistakes. All right, so it shifts once, twice to the right, and I need to annex in a 0. The answer is 730 centimeters. So that's a very big, long Python. All right, example 1, done. Turn the page. Do the next one. You can skip their key concept idea because it's just, they're kind of ignoring the simplicity of why the metric system is so great. Rashonda has 50 dominoes. Each domino is 4 centimeters long. Here I was telling you might not have to stack and multiply, but you do. It's okay though. It's pretty straightforward. She lines them up end to end as shown. How many meters long is the line of dominoes? So she's got, again, the picture shows like there's only 3 dominoes, and there's not 3 dominoes. The problem says there's 50 dominoes. 50 dominoes at 4 centimeters each. When I multiply by 4, I double. 50 doubled is 100. 100 doubled is 200. So without stacking, I can know that 50 times 4 is 200. So we've got 200 centimeters worth of dominoes all lined up. And the question is, how many meters is that? And some of us right now already know the answer without showing our work. Cool. You still should show your work just to make sure that you're showing a complete understanding and less likely to make errors. So if I'm starting at centimeters and I'm going to meters, the base unit, I go 2 times to the left, twice to the left. So that invisible decimal here shifts once, twice to the left for an answer of 2 meters, because every meter is 100 centimeters. So that's how this works. Go ahead and remember to show your work using the KHDUDCM method. So just write that down maybe like at the top of your page so that you can keep referring to it, and then show with your pencil how the decimal shifts in each problem is how you want to do that. There are problems later on that show comparisons. So just like any of the other comparison problems we've done, you need to make it so that you're not comparing apples to oranges, but you're comparing apples to apples, which means that instead of comparing centimeters to millimeters, you're comparing centimeters to centimeters, or millimeters to millimeters. It's your choice. You can switch either one. There's the main point of confusion the kids tend to have on this is they go, which way do I shift the decimal? So you just have to remember, you point on your chart to where you start, and then you count how many times and pay attention to the direction you go to get to your target. So the decimal shifts to the left if you're starting with something small and going to something bigger. And it shifts to the right if you're starting with something bigger and shifting to something that is smaller. Do the guided practice problems on your own. Again, they've got all this stuff here, like you're going to solve it their way. Don't do it that way. It's the advantage of the metric system is that you can rapidly move the decimal to reflect the conversion. It's why it's so great. So you want to use that method on those two. Just start with the guided practice problems and go right into these and do the next page as well. So you're just like normal doing front and back. If it takes you longer than 45 minutes, then just stop and move on to the math choice. If you finish early, good for you. Then you can move on to the math choice. I hope you are well. Miss you at school, and we will talk to you later. Have a good one.